Ever wondered how a fire alarm can sense danger long before flames are visible, and how an entire building reacts within seconds? Today on Knowledge Hub, we break down how fire safety systems actually work, from the moment a tiny change in air conditions is detected to the full-scale automated response that protects lives and property. It all starts with detection. Fire alarms don't directly detect fire, they detect byproducts such as smoke, heat, and specific gases. The most common smoke detectors fall into two main categories: ionization detectors and photoelectric detectors. Ionization detectors use a tiny amount of radioactive material to ionize the air between two charged plates, creating a steady electrical current. And when fast-moving smoke particles from flaming fires enter the chamber, they disrupt this ion flow, causing the current to drop and triggering the alarm. Photoelectric detectors work differently, using a light source and a sensor range, so that under normal conditions the light never reaches the sensor. But when larger smoke particles from smoldering fires enter the chamber, they scatter the light toward the sensor and activate the alarm. This is why modern buildings increasingly rely on dual sensor detectors that combine both technologies to respond quickly to different types of fires. Alongside smoke detection, heat detectors continuously monitor temperature changes, either activating at a fixed temperature threshold, such as 57 or 70 degrees Celsius, or by detecting a rapid rate of temperature rise that indicates abnormal heat buildup even before visible smoke appears. In high-risk environments like parking garages, factories, and server rooms, additional sensors may detect carbon monoxide, flammable gases, or the infrared and ultraviolet radiation signatures produced by open flames. Once any detector senses a potential fire, the signal is sent to the fire alarm control panel, which acts as the brain of the entire fire safety system. The control panel verifies a signal, checks for faults, identifies the exact zone or device that triggered the alert, and then immediately initiates a coordinated response across the building. Audible sirens and high-intensity strobe lights activate to warn occupants, while voice evacuation systems may provide clear instructions. At the same time, the system can automatically unlock fire exits, return elevators to safe floors and disable them, shut down HVAC systems to prevent smoke from spreading through air ducts, and switch on emergency lighting to guide people to exits. Smoke extraction and pressurization systems may activate to keep stairwells and escape routes clear. In buildings equipped with suppression systems, the response escalates further. Sprinkler systems operate locally, with each sprinkler head containing a heat-sensitive glass bulb or fusible link that activates only when temperatures rise in that specific area, allowing water to target the fire without flooding the entire building. In data centers and sensitive facilities, gas-based suppression systems such as FM200 or inert gas systems may be used instead, rapidly interrupting the fire's chemical reaction or reducing oxygen levels without damaging electronic equipment. All of this can happen within seconds, meaning modern fire safety systems can detect microscopic changes in the environment, confirm a real threat, alert occupants, control building systems, and begin suppressing the fire before firefighters even arrive. So the next time a fire alarm suddenly pierces the silence, remember, it's not just a warning, it's a complex, tightly integrated safety network detecting invisible danger, making split-second decisions and triggering life-saving actions across the building long before the situation becomes visible or out of control. If you enjoy this deep dive into the hidden engineering that keeps us safe every day, make sure you subscribe to Knowledge Hub for more breakdowns of how things actually work. And as always, stay curious.